Good morning. A life cycle assessment is discussed in this video. Life cycle management is otherwise called as life cycle assessment. Every human has different stages in his life cycle. First from childhood, then from youth stage, and he attains the middle age, and finally he goes through the adult stage and the end of life. Similarly, every product it is in the ore form, for example, iron ore or copper ore, and it is extracted from the ore, raw material extraction. Then the raw material is transported to the production site, and here it is manufactured into the product, and the product is taken to the customer, and the customer uses this product for the end of his full lifetime, for 1 year or 5 years or 10 years or 20 years, depending upon the life of the product, and the product becomes finally it becomes obsolete and it becomes useless, and this is a life cycle of your product. So the different stages of a product's life can be assessed by life cycle management or life cycle assessment, where how much resources are used or how much greenhouse gases are released in each and every process can be analyzed in this LCA, life cycle assessment, and it can be improved to add a more sustainable approach. By completing and a life cycle assessment, environmental impact of one product can be compared with other products and can be improved. So there are different types of life cycle assessment. Cradle to grave, that is from the raw material extraction to the use phase. Cradle to gate. So from the raw material extraction to the factory gate and before reaching the customer. Then cradle to cradle, it is a closed loop cycle, and the disposal, the end of life will be a recycling process. Once again it is used 10 to 15 times, it is used again and again. That type is called as cradle to cradle. And gate to gate, no recycling be done. Ecological based LCA, it is a modern technology. Ecological impacts are considered. The goal of life cycle assessment, so it is the main aim is to quantify carbon emissions for composite materials. It can be of three types: GHG emissions, the direct GHG emissions, and indirect greenhouse gas emissions associated with electricity or heat for the facility, and indirect emissions, it is associated with the production of raw material, transportation and distribution of products. It is not within the control of the company. A need for LCA. So the increasing awareness of climate changes and global warming, efforts are made to reduce the environmental impacts and the carbon footprint. So the life cycle assessment is very much essential, and nowadays it plays a very important role to assess the environmental impact of different products. The main aim of life cycle assessment is to reduce the carbon dioxide and other greenhouse gases by employing sustainable practices in production, use, and end of life or recycling process. There are different types of recycling methods. First one is primary recycling, secondary recycling, tertiary recycling, and quaternary recycling. 4 types of recycling methods. In the primary recycling method, that is polymerase, again the final product is again converted into the polymer, that is called as primary recycling. Then the after use the product is again converted into the polymer, it is secondary recycling. In the tertiary recycling, after use the product is converted into monomer, it is tertiary recycling. And in the quaternary recycling, that is the product is burned. For example, plastics, the waste plastics are burned and they are producing energy. and this energy is saved, or it can be used for any other purpose, that is called as energy recovery. This process is called as quaternary recycling. So recycling methods are primary recycling, secondary, tertiary and quaternary recycling. Primary recycling, it is a mechanical recycling. It is a closed loop recycling technology used on high quality polymer composite waste with known history. It reuses materials in their original form. There is a limit on number of cycles. Because of simplicity and low cost, primary recycling is the most used method. It allows recycled materials to be utilized in applications that have the same properties and performance as virgin plastics. Is not linked to the post-consumer plastics. Example, production leftovers into its original pellet or resin from within the same manufacturing facility can be used again. So it does not need sorting or cleaning. So in the primary recycling, that is before going to the customer, the product is recycled, that is production leftovers, and the products that are become waste or wrongly made products are once again recycled to make the polymer. This kind of recycling is called as primary recycling. The secondary recycling, the product reaches a customer and customer used the product for some time, the product become contaminated. The contaminated products are once again recycled to the polymer. This type of recycling called as secondary recycling. In secondary recycling, it is also called as mechanical reprocessing of waste. Materials recycled through secondary recycling have lower mechanical properties because the products are contaminated. So it has lower mechanical properties than that of the original products. Lower mechanical properties are attributed due to the lower material purity and decomposition processes that result during the life of the product. So it is inexpensive. The amount of waste is contaminated is small. That is, the cost increases due to the separation and purification steps. If the number of separation and purification steps are more, the cost increases. Although mechanical recycling is a well established approach for conventional plastics, it should be used with caution when it comes to biodegradable plastics like PLA. This is due to sensitivity of biodegradable materials to heat. One of the advantages of this method, mechanical recycling over chemical recycling, is mechanical recycling is lower in cost to processing, less potential for global warming, and less use of non-renewable energy. About 30% of PET bottles. So the PET bottles are used as a plastic bottles, as water bottles or Coca-Cola or any other cool drinks cans are made up of PET material. PET is nothing but polyethylene terephthalate. So the PET bottles are almost 30% are recycled, but most end up in landfill where decomposition take up to 400 years. PET products are processed by mechanical recycling. This method negatively affects the mechanical properties, and the produced PET is called as reclaimed PET or rPET. That can be used as only low quality products. Tertiary recycling. The tertiary recycling, that is from the diagram we can see that that is end use. So after end use, the products are that is, first one is mechanical reprocessing, second one mechanical recycling, third one is tertiary recycling or chemical recycling. In the chemical recycling, after end use, and the products are once again converted into monomer, containing a repeating unit of 1. This is most the advantages of chemical reprocessing. In the tertiary recycling is also called as chemical recycling, and it converts polymers into monomers or sometimes depolymerized into oligomers. Oligomers contains 10 to 15 repeating units. But it is carried out by means of chemical processes that modify the polymer's structure. The resulting monomers can be utilized to recreate original or related polymeric product by new polymerizations. That is, the original polymer can be made. Polymer having the same properties as that of the original product can be made using this method. Starting with monomers, oligomers are combination of various hydrocarbon. This process is capable of reducing the plastic substance into smaller particles appropriate for use as raw material. One of the advantages of chemical recycling over mechanical recycling is virgin monomers can be repolymerized. So the same polymer can be obtained for an endless number of recycles. Many number of recycles you can use this chemical recycling process. One of the disadvantages of this chemical recycling is it is expensive, economically and environmentally expensive, because it creates more carbon dioxide and other gases, ammonia, it liberates more other gases. So it is very highly economically and environmentally expensive. And one of the only approach permitted under principles of sustainable development, since it results in the production of monomers from which the polymer is created. The alkaline hydrolysis employing sodium hydroxide depolymerized PET into original monomer and thus provide greater promise for bottle to bottle recycling. Chemical recycling approach for PET recycling compared with other methods, monomer has obtained terephthalic acid is of high purity. Catalysts have greater potential to accelerate the chemical recycling process. The fourth recycling process, quaternary recycling, in this the end product is burned and energy is produced. And the process of recovering, it is a process of recovering energy from low grade plastics garbage by incineration. In Japan and other countries, European countries, 30 to 50% of the plastics waste are burned and energy is produced. So this method is best suited for reducing the volume of organic matter and producing large energy from polymers. This method is of waste recycling should be used as a last step. It is not environmentally acceptable because it liberates pollutants which are risky for our health, and it also releases toxic materials and such as dioxins. End of life. There are the steps of LCA. There are 4 steps according to ISO 14040 standards. Life cycle assessment consists of the following 4 steps. Identify the whole goal and scope. Second one, life cycle inventory analysis. Third one, life cycle impact assessment. Fourth one, interpretation of results. Goal and scope of analysis, life cycle inventory, life cycle impact assessment, and interpretation of result. And from ISO 14040, first step is to define clearly the state and goal of the study. That is, the system boundaries, well-defined system boundaries have to be established, and a functional unit should be established. For example, polyethylene food containers or the environmental assessment of polyethylene food conductors are to be developed, and the functional unit may be 1000. Functional unit is useful for a comparative analysis, a comparative study of 2 different materials. Then life cycle inventory, and the second step is life cycle inventory analysis. It is a time consuming and extensive process, and it identifies and quantifies the resource flows for the system, and LCA creates an inventory of all inputs and outputs of materials, wastes, natural resources for all processes in relation to the functional unit. All flows of water, energy and raw material into the system, the waste related to the release to the atmosphere, land and water, and use of land are traced and recorded for each unit process. Third one is life cycle impact assessments. And there are so many life cycle impact categories: damage to human health, damage to ecosystem, global warming potential, that is climate change, damage to resources, ozone depletion, human toxicity and acidification, landfill and freshwater eutrophication, and marine water eutrophication, and land use There are so many impact categories, and the impact categories have to be evaluated. Finally, the analysis and interpretation of the results have to be done, and the limitations of the study should also be discussed. These are all the steps in LCA process. Thank you.